In this lesson, we're going to learn some basics of the I/O libraries that Java provides. Along the way, we'll learn just a little about the exception mechanism, which gives control of how error situations are handled. Java handles I/O operations in two different flavors. We can handle 8-bit data, and we can handle textual data. Textual data is represented using a 16-bit Unicode character set. That's why the char is an unsigned 16-bit number. Java seeks to generalize its handling of all I/O, and in so doing it comes up with 4 core abstract classes on which much of the rest of the I/O libraries are built. 2 of these classes are input stream and output stream. These handle 8-bit data, and as the name suggests, one provides for reading data in, while the other provides for writing data out of a program. The other 2 core abstract classes are reader and writer. These handle character data, 16-bit Unicode, and as their names suggest, reader provides for input and writer provides for output. You can find documentation on these classes in the regular Java documentation. So let's look at these in the standard Java API documentation. Start in this corner and scroll down until you find java.io. Then you can click on the java.io package name here and see a list of the basic classes available to you in java.io. Here you see input stream. It says this abstract class is the superclass of all classes representing an input stream of bytes. We also see reader, abstract class for reading character streams. Because these are abstract classes, we know that there must be some concrete subclasses that provide real usable behavior. So it's not a big surprise that we can find the file reader class, which describes itself as a convenience class for reading character files. We can find that one here. If we scroll down and look at the classes, file reader, click on that. There we go, convenience class for reading character files. It has a constructor that will take a string describing a file name to tell it what file to open. We can also find a buffered reader class. This one notes that it reads text from a character input stream, which means another reader, by the way, buffering characters so as to provide for efficient reading of characters. It's long been recognized that I/O should always be done in the biggest chunks possible so that you get the best possible performance. That's an interesting idea. If you follow the logic, the idea is that you can attach one reader to read from another reader. That's kind of a neat idea and allows the combination of certain types of processing, like buffering, to be combined without having to create special classes for each combination. But there's actually another really good reason for using a buffered reader, and that is because the buffered reader provides a handy readLine method. Let's see if we can find that one. Scroll down in here, look at the methods, and we will see readLine, reads a line of text. None of the other readers do this, so without it we'd be stuck reading one character at a time or perhaps reading a chunk of data into a char array. Let's see if we can make this thing do something useful. I've just created this project reader file as a starting point. And the plan is we're going to make this read some lines of text from a file and print them out. So this is just the empty skeleton that was created for me by NetBeans, and I'm going to put some code in here that I'm hoping might do something useful. So here's what I'm doing. I'm creating a new file reader based on a particular file name, and I'm storing that in a variable of type file reader, and then I'm attaching a new buffered reader to connect to the file reader and storing the variable that refers to the buffered reader as BR. Then what I do is I work into a loop where I declare a variable called line of type string, and I say read a line from the buffered reader and store it in that variable. And then if that's not null, we go through this while loop and we print out the line that was just read. Well, I'm going to need some imports, so I will do source fix imports. And we'll notice that it imports java.io.bufferedReader and FileReader. Unfortunately, the compiler is still complaining about something. So let's hover over this error and see what it says. Unreported exception, java.io.filenotfound exception, must be caught or declared to be thrown. This one down here says unreported exception, java.io.io exception, must be caught or declared to be thrown. At its most basic, this tells us that the compiler is worried that these two elements, the constructor of the file reader and the readLine method, might break in some way. That's reasonable. If we try to open a file that doesn't exist, clearly that won't work. And if we try to keep reading past the end of the file, that's probably going to cause trouble too. But what's perhaps a little odd about this is that we can't just ignore the error and hope it doesn't happen. Java, in the interests of good quality software, does not let us ignore these problems. We have to do one of two things. We can either allow the problem to break our method and effectively pass the problem to our caller, or we have to try to do something about it. Well, in this case, we really don't care, as this is not production quality code. It's just meant to be a little example of how to use a file reader and a buffered reader. So, we can simply tell the caller of this method that it might break. There's a quick and dirty way to do this, which is to label the method itself, here the main method, as throws throwable. When we add this element, what we're doing is warning the caller that this might not work and that it should probably be ready to handle the problem. Well, the caller in this case is the Java virtual machine that's running our program. So what will happen is if it fails, it will just stop the whole program. Not a problem in this case. Anyway, let's save that and run it and see what happens. Well, it does indeed break. That, of course, is because there's no file test.txt. Notice here we attempt to open that file for reading, and we haven't done anything to create that file. The error is actually quite descriptive. It says exception in main thread, java.io.filenotfoundException, test.txt, no such file or directory. And it even tells us that it occurs in readerfile.java at line 21. So it's pretty descriptive of what's gone wrong. And it turns out that a java.io.filenotfoundException is actually an object that has been thrown, and that's what's trying to describe the problem. There's a lot more to know about exceptions, in particular how we can recover from problems that they represent. But this is not the lesson to discuss that, so we're going to let that go for now. Anyway, let's create the text file. So to create that file, we're going to right-click on the project, say New, and we'll come down to Other. We'll select Other here, come down here, and scroll down and find Empty File. We'll click on Next, and then we'll say text.txt and hit Finish. Then we can type some text into here and save everything. And as we come back to our main program, we can run that, and we see that this time it actually works. It reads the lines of text, prints them out. We can see that they came from here because they're prefixed by the read colon and a space. So this lesson has given a basic introduction to using Java's I/O libraries, and we've started to see how problems are represented in a Java environment using exceptions, and one way that we can deal with what happens when an exception arises.